Hello, my name is Sarah Rado, and I'm a master's candidate here at NCC. Today we are discussing how spatial analysis techniques were used to encapsulate the effects of sea level rise on coastal forests in Carteret County, North Carolina. The provocation for this poster is that the impacts of saltwater intrusion on coastal forests has been very well documented, but we have yet to assess coastal forests that are the most vulnerable in the county. This project illustrates the most vulnerable coastal forests that are threatened by various levels of sea level rise under failure to curb future emissions. Carteret County is located in eastern North Carolina. It is approximately 1,341 miles squared. It has a total of 51,690 acres of deciduous forest, which equivalates to 80.76 miles squared. These forests are vast with coastal wetlands, swamps, seagrass, and vegetated shorelines, and provides Carteret County with a critical ecosystem that is rich in biodiversity. This critical ecosystem sequesters and stores copious amounts of carbon, mitigating the effects of climate change, regulating water flow, and protecting inland coastal communities from extreme weather events and sea level rise. The correlation between saltwater intrusion and the conversion of coastal forests to ghost forests is of the utmost concern in Carteret County. As saltwater intrudes our coast, there is significant evidence that shows there will be a detrimental biophysical change to our local ecosystem. Coastal forests will no longer be able to tolerate the increasing salinity and therefore not be able to provide critical ecosystem services, setting a cascade of amplifying effects locally and globally. Sea level rise is caused primarily by two factors related to global warming: the added water from melting ice sheets and glaciers, and the expansion of seawater as it warms. The temperate coastal forests of Carteret County are dependent on fresh water and can only tolerate short periods of saltwater inundation and exposure. Prolonged exposure leads to osmotic stress and eventually causes the trees to succumb to death. The increase in salinization and inundation causes these coastal forests to move upslope and leave behind the dead trees and other salt-tolerant vegetation, leaving behind a marsh, decreasing carbon storage and increasing albedo, leaving us with ghost forests that are the dead and dying remains of a once thriving coastal forest. Due to the compounding effects of our anthropogenic activities, this coastal ecosystem is shrinking. Spatial analysis utilizing Esri software was used to encapsulate data representing the extent of saltwater intrusion and its explanatory factors. National land cover data was obtained from the Multi-Resolution Land Characteristics Consortium from the most recent years of 2019. Sea level rise scenarios procured from the National Oceanic and Atmospheric Office of Coastal Management depicting 2, 4, 6, 8, and 10-foot sea level rise were utilized to aid in the identification of coastal forest transition to ghost forest, setting a 50-meter buffer from the shoreline. The 50-meter buffer was used as this is the zone of dispersion where freshwater and saltwater mix by the processes of diffusion and mechanical dispersion. Spatial analytics was run to show the percentage of pixel conversion from land to saltwater for the years 2020 through 2100, utilizing 0-foot sea level rise as a control. The sea level rise scenarios from NOAA's coastal management of 2, 4, 6, 8, and 10 were run without a 50-meter shoreline buffer, annotating pixel conversion from deciduous forest to water. The scenarios were then run again, implementing the 50-meter shoreline buffer, annotating pixel conversion from deciduous forest to water. The pixel conversion of deciduous forest was then compared, and a percentage change from deciduous to forest to water was calculated. This calculation identifies the areas of transition threat 50 meters out from the shoreline at various sea level rise scenarios. A county boundary of Carteret County procured from ArcGIS organizational content was brought into ArcGIS Pro. A coordinate system was then established at NAD 1983 State Plain, North Carolina, FIPS 3200 US feet. National land cover data, an LCD, was obtained from the Multi-Resolution Land Characteristics Consortium and was imported into ArcGIS software. A coordinate was then established at NAD 1983 State Plain, North Carolina. An extract by mask was then run to show only NLCD data within Carteret County. Sea level rise scenarios procured from NOAA's office, NOAA, were then imported into Esri into ArcGIS Pro. A project was then run on each sea level rise scenario to project spatial data from one coordinate system to another. A geographic transformation took place from WGS 1984 to NAD 1983. An extract by mask for NLC data and county boundary was then run on all sea level rise scenarios to maintain all data within a county boundary. The attribute tables for each sea level rise were then exported to Excel. A pixel conversion percentage change was then calculated for each sea level rise scenario. 100 times new minus old divided by old. A dissolve aggregates features based on specific attributes was then run on all NC SLR scenarios. A project was then run on each SLR scenario to project spatial data from one coordinate system to another. A buffer of 50 meters from the shoreline was then run on each SLR project, creating polygons around input features to a specific distance. An extract by mask for all 50-meter shoreline buffers was run, extracting NLCD data and county boundary to maintain all data within the study area. The attribute tables for each buffered SLR scenario was then exported to Excel. A pixel change percentage was then calculated for each sea level rise scenario containing a 50-meter shoreline buffer. The pixel conversion data sets, 1, sea level rise without the 50-meter shoreline buffer, and 2, the sea level rise containing 50-meter shoreline buffer were then compared. A pixel conversion percentage between the two was calculated. This calculation identified areas of highest pixel conversion, identifying coastal forests that are of most threat of transitioning to ghost forest with a 50-meter shoreline buffer at various sea level rise scenarios. Spatial analyst tools were used to illustrate the quantifiable impacts of SLR on Carteret County, North Carolina. In order to spatially display the areas of coastal forest that are of most threat to transition to ghost forest, raster calculator image analyst was used. This Esri feature builds and executes a single map algebra expression using Python syntax. The map algebra expression that was used is set null is null. This expression extracts values that do not overlap with a non-buffered layer and displays the areas of risk of ghost forest conversion. The set null tool requires a first conditional raster where the cells do not equal 0. This is equivalent to a Boolean true and is set to null. The extract card of your various sea levels were utilized at the null raster. The second is the false raster. This raster represents the desired output cell values where the conditional raster is equal to 0, which is equivalent to a Boolean false. The buffer for each sea level rise scenario was utilized as the false raster. For the desired output, the conditional raster needs to be true if the pixels have null values and false everywhere else. In order to find the null values, the inverse of the null values was utilized, giving us the most vulnerable areas that are of threat to transition. The Python syntax utilized was set null is null, extract Carteret at each sea level rise, and buffer at each sea level rise. After the set null is null was run for each sea level rise scenario, the results were new images of the most vulnerable areas. An extract by mask was run utilizing the county boundary as the mask to maintain all most vulnerable areas within the county boundary. As you can see, looking at the images displayed in this poster, you see the areas at most risk to convert to ghost forest transition. These images, each sea level rise scenario does look most extreme, understanding that each sea level rise scenario that were compared did not account for the previous sea level rise scenario. So the results. As you can see, there's an increased loss of deciduous forest due to increasing sea level rise, and there is significant loss of land and land cover. As sea level rise pixels that were once deciduous forest decrease and convert to open water. The outcomes of this study provide Carteret County areas of deciduous forest at a risk of transition to ghost forest using 50-meter buffer from estimated sea level rise. 8,715.5% increase in areas at risk of ghost forest transition from 2-foot to 10-foot sea level rise. More research is needed to show how anthropogenic land cover modification contributes to deciduous forest loss and sea level rise. Thank you.